Hi, students. Welcome to video 13 is on industrial agriculture. So, traditional agriculture for most of human history was what we call traditional subsistence. Humans were basically growing enough for themselves, maybe their friends, some extended family, but they used their own labor and they used animals. We can't do that now for to feed 7.6 billion people, so we have to make it an industrial agriculture method. So this is mechanization, standardization applied to food production that allows us to produce a ton more food. So if you've ever gone to a fast food restaurant, you might have noticed that a Big Mac might cost a dollar or two, whereas a salad might cost five or six. The reason for this is because fossil fuels, which are used heavily in growing things like Big Mac or raising the animals, are subsidized, meaning that the government provides money to companies in order to make it a artificially low cost. So you're not really paying the full price; you're paying the subsidized cost. And the reason is, there's inputs of fertilizers and pesticides use fossil fuels, and then the tractors are also going to be using fossil fuels. So when we look at some history in terms of our agriculture, we had a green revolution right around the middle of the 19th century. There was more machines, you had more fertilization, you had better irrigation methods, improved crop varieties. All of these things increased our food production. Now, be careful here. It is not green as in eco-friendly. It's green as in there's a lot of crops down here and they're green. Okay, so we're not talking about environmentally friendly methods. We're talking about producing more food. So when we look at the mechanization for how we actually produce more food, so there's a huge upfront cost justified with these tractors and big heavy machines. And it's justified by the profits that you're going to be making from the increased food production. Unfortunately, small farms can't extend this cost up front because they just don't have the extra money. So most small farms don't utilize these huge, or at least a ton of the huge tractors and things like that. So when we look at our farming over the past couple of hundred years in the United States, we'll notice that the number of farms has dropped significantly. So we are not having a ton of farms, but now the average size of those individual farms has increased. So it's not so much, Farmer John on his own little plot of land. It's more of a huge industrialized big farmland that's like hundreds of acres. So three systems produce our food. First, we have monocultures. That's almost 80% of our food. So monoculture is growing one crop. We also have rangelands and feedlots. That's about 16%. And then aquaculture is about 7. So aquaculture can be in the ocean or it can also be on land in kind of like these big pots of water. And we kind of grow things that way. So monocropping, again, mono means one. So I'm getting really, really good at growing one thing, one single variety or species. Plantations are going to be utilizing monocropping. So we have tree plantations in North Carolina where we grow Christmas trees. These are all your cash crops. So coffee, banana, palm oil, beans, sometimes just depends. This is very efficient in terms of economics. So I'm going to make a lot of money. I'm going to get really good at growing that one thing. And it's going to give me a lot of production. The problem with monocropping is it leads to soil deterioration and erosion. So now I'm taking out all the nutrients in the soil and I'm not putting them back. I'm causing more soil erosion. It's high input, which means you have to use a lot of fertilizers, a lot of pesticides, a lot of fossil fuels. It also decreases our genetic diversity because if there's only one thing, well, that's not very diverse. Also, if there's only one thing, the number of pests and predators are not going to really be there. So you may have a couple of pests that are causing a huge problem, but there's not going to be a lot of genetic diversity because there's only one option for food. So if we look at our meat production, most of our meat is grown in a confined animal feeding operation. Those are called CAFOs. These are feedlots. If you eat any kind of meat, so cows, hogs, chickens, any of that sort of stuff, if you eat that from a grocery store, it's probably coming from a area kind of like this. So unless you're going to the farmer's market yourself and talking to the farmer and buying it from the farmer, you've probably gotten food from a CAFO. So these animals are confined for pretty much all of their life. Some of them don't even actually go outside at all. They stay inside their entire lives. They're given lots of antibiotics. They're given nutritional supplements. Antibiotics are because of diseases. Think about how closely spaced these areas are. These animals are not, they're interacting with a lot of other animals. So if one of them gets sick, a lot of them are going to get sick. They also can become malnourished because they're basically fighting for food with the animals that are around them. So they're fed these kind of extra supplements for that. In terms of economics, it's really, really good. You make a lot of money. You minimize the amount of land, so that's good. And you improve your feeding efficiency. It's really easy to feed all the animals if they're all confined right there together. So, our factory farming, which is kind of what we're talking about, has been increasing steadily over the last 30 years. So, what are some bad things? It does lead to antibiotic resistance. So, you're giving these animals antibiotics. Some of the bacteria you'll see up here in this diagram are not going to be killed off, and they're going to become resistant to that antibiotic. And then the next time you give the animal that antibiotic, those bacteria are going to be the ones that reproduced. So now you have to come up with this new antibiotic to give the animal. You also have diseases like we talked about, like mad cow. There's ethical concerns in terms of animal cruelty. Should we be doing this? There's nutrient runoff problems. We pretty much have to deal with our waste in some way. And one way we do that is we put it in a lagoon. So this picture over here is kind of waste going off into a lagoon. Basically, it's a lake of poo. And sometimes we have hurricanes or we have flood events, and that waste will actually run off into our waterways. So when we look at the amount of land and water, we know that the land needed for meat production is a lot higher than the land needed for vegetables. And we talked about this in Unit 2 when we did our farmer study, our farmer eating the chickens and the grasshoppers and all that stuff. So we know that it takes a lot more land. It also takes a lot more water to produce beef and chicken and pork than it does to produce vegetables. So the inputs for industrial agriculture, we're going to talk about pesticides and fertilizers. We've already kind of talked about GMOs in class, so we're not going to spend too much time on that. In terms of synthetic pesticides, we have been using natural pesticides for many, many years. In the 1950s, we used arsenic, lead, and mercury from minerals that we crushed up and would kind of put on the crops. But we quickly figured out that arsenic and mercury, these things are not good for us, and they were getting into our food, which we're then getting into our bodies. So now we use synthetic pesticides, and that has really doubled our food production and made it where we can feed all the people on the planet. So there's two different types of pesticides. There's narrow spectrum, which kills only that one target. There's broad spectrum, which kills a variety of different things. So say you have a mosquito problem. Okay, well that's fine. I can spray a narrow spectrum pesticide. But what if I have a mosquito and a wasp and a fly problem, for example? Well, I don't want to spray three different narrow spectrum because that mixture can just be not great. So I want to spray one broad spectrum. So there's benefits to each, and sometimes you want to spray one more than the other. So some advantages and disadvantages of pesticides. Most of the advantages are going to be dealing with increased food supplies, which would save lives, cause people to have food, which is always good. It's also profitable. It costs less to spray synthetic pesticides, and then you end up making more money. The disadvantages are going to be mostly environmental. So it kills the unattended targets. Even if you meant to spray for only mosquitoes, you might be killing all the bees. It also promotes genetic resistance for the same reason that the antibiotics do in the animals. It it ends up polluting our environment, which can harm wildlife and people. But the pesticide industry declares that the health risk is insignificant compared with the benefits, which of course, they would say that. Like, what else are they going to say? No, don't use our products. So, what's the ideal pesticide? It kills only targets, it disappears fast, it breaks down into something that's harmless, and it doesn't cause genetic resistance. There is no such thing. So, if you can make this, you will become a millionaire and you will have to share your money with Miss Jones because she taught you about some of this stuff. So DDT is a really special pesticide that we've talked about before. It is banned currently in the United States. Remember, this is the one that Rachel Carson kind of warned us about. Although the US still is the number one producer of DDT. And the reason why is because lots of developing countries have a malaria problem, which is a disease that's transmitted by mosquitoes. And so if you spray the DDT, that kills the mosquitoes, which then causes malaria to go away. So people were dying in their 30s, 40s, maybe 50 malaria, whereas DDT, maybe it won't cause any huge problems until later in life. So you kind of have to weigh the benefits and the risks. DDT, though, is really persistent and it ends up breaking down into something called DDE, which is even worse than DDT. The other thing to think about is even though we're not spraying it in the United States, we're importing food from places that are spraying it. So it's on our food still. And then our global winds are going to cause some of that DDT to come back to us. So just because it's being sprayed in other countries doesn't mean it's not getting in ours. So, looking at some pesticide laws, we have the Federal Insecticide, Fungicide, and Rodenticide Act. This allowed the EPA to regulate pesticides and to say, yes, this is fine, or no, this is not. But the problem is, they cannot regulate the amount of pesticide that people use. So, people at their own homes end up spraying a lot more pesticide than farmers would on their crops. And then that's going to get into the water supply and cause problems. We also have fertilizers that are synthetic. And so I'm going to leave this up and I encourage you to pause the video and kind of jot down a few of the differences here. So, an organic fertilizer is something that comes from living organisms like our compost. A synthetic fertilizer is something that's derived from oil, basically, comes from fossil fuels. One of the biggest differences is going to be the amount of nutrients. So, in organic, there's more nutrients that the plant needs. In synthetic, there's mainly just those macronutrients and not the micronutrients. The other big difference is the organic fertilizers will basically be incorporated into the soil, whereas the synthetic fertilizer, if they don't get incorporated into the soil, they end up running off and they can pollute our waterways. So water pollution is one of the biggest problems with these synthetic fertilizers. All right, that's it. Come in with your questions tomorrow.